Good morning, everyone. My name is Nicole Birdie. I'm a senior program manager on the Azure IoT team, primarily working on IoT Hub. Today, I want to talk to you about building scalable IoT solutions on Microsoft Azure. I've been on the Azure IoT team since before it was called Azure IoT, and so this talk is basically a culmination of all the different conversations I've had with my customers over the years of kind of the do's and don'ts around building a scalable cloud architecture. Now, one of the primary things I learned from talking with customers is to always define your terms, because if you are at all familiar with IoT, you will know that one thing you can guarantee on is that every single IoT term is overloaded. You cannot, not everybody even agrees on what a device means. So let me first describe what IoT is, at least when I talk about IoT to you. IoT is composed of 4 different parts. There are the things, obviously. You can't have an Internet of Things without things. And these things are going to be the source of your data that is you're sending to the cloud to do whatever it is you want to do with your data and with your devices. Now, you can't have an Internet of Things without some sort of connectivity between your devices. And this is the second ingredient in what makes an IoT solution an IoT solution. You've got your things, they're connected to the Internet, and what are they doing? They're sending data. So the data is the third ingredient, because if you've got things connected to the Internet and they're not sending data, who cares? So you need your things connected to the Internet, sending data, and what are you doing with that data is the last part. You have to do some sort of analytics on top of the data to impact some sort of change. That again goes back to these things in the first place, because this is why you're doing an IoT solution, because you're collecting data from devices in a way that generates insights that are more than anything you could do by monitoring each individual device at a time. So when I say IoT, I really mean these 4 ingredients, but really I can put it more simply, that IoT is just harnessing signals from remote devices to either improve existing businesses or to start new ones, though the harnessing part is tricky, especially when you're scaling up. And it's that last part that becomes really interesting when we start talking about IoT, because it's really easy to hook up, a device or two, you plug in the LAN cable, code it up, and you're like, hey, cool, I've got data coming out of this. But when you start talking about millions of devices that you're deploying to a field simultaneously in a real-world scenario, like installing them on traffic lights, in elevators, and big machinery, that's where things start to get really, really tricky. So for the rest of the talk, I'm going to talk more about enterprise-grade IoT, because that's where a lot of the scalability things happen. That's not to say that what I'm about to say is not applicable to consumer. It's just that consumer space, you're dealing with maybe max 20 devices at a time. And I want to talk about more like max 2 million devices at a time, or maybe even bigger. So the key to really wrapping your head around how to successfully build an IoT architecture is to think big and start small. Sure, you want to build some increasingly impressive, traffic managing solution. Like by traffic, I mean, stoplights to ease congestion during rush hour. But if you try to focus on what your whole end-to-end is without first connecting 2 devices to the Internet and saying, look, I've got data, hooray, then you're going to have a hard time, because you'll build this big, sprawling architecture, and you'll be talking to somebody and say, hey, how do I implement this? And they'll go, what you built just kind of looks like a rat's nest, layered on top of a spider web, and I don't really know what to do with that. And true fact, I had a customer do that before IoT Hub went GA, or met with a customer, and this is what they did. And they're like, they drew this big box diagram on the whiteboard and said, we want to build that. And we're like, whoa, you made a bunch of assumptions here, and have you done a proof of concept? And they're like, nope. And we went, oh, right, let's start by really encouraging you to do a proof of concept. So learn from the mistakes of others and build a proof of concept. So really, when you're building an IoT solution, there are 3 things that make up the overall architecture. First and foremost, obviously, is the why you're building an IoT solution in the first place. Generally, you're not doing it for tickles and grins. You're doing it to achieve some sort of business outcome. You want to save data in your manufacturing pipeline. You want to increase revenue streams by changing your business model and offering a service to your customers rather than just selling them a thing. So that obviously is a big deal, is why you're building it in the first place. But you need to be able to make sure that your architecture can scale when you go live as well. You don't want your smart toaster application that works great for 10 toasters but fails miserably when you hit the 11th to suddenly become wildly popular on Kickstarter, and then suddenly you need to redesign your entire cloud backend because it won't scale to support how popular your devices come. So make sure you can actually build your architecture to scale for success rather than have to go, oh shoot, now I've got to redesign the whole thing. That's never fun. And then, of course, there's part of your architecture is how do you deal with the data itself? Obviously, you want to collect some sort of data and do something with it. And you need to answer the question of what is the something you want to do with the data? And I'll get into that in a little bit more in the talk. But basically, these are the 3 ingredients that make up an IoT architecture. And remember that you have to keep all 3 of these in mind at every point along the way. Like, why are you building one? How are you going to scale when this gets big? And what are you doing with your data? So all of these are applicable. And I want to start with talking about just kind of IoT infrastructure as a whole, to give you a good foundation, regardless of what industry vertical you're in or what type of solution you want to build on. And similar to the ingredients of a basic IoT, like what defines IoT, in a basic IoT architecture or infrastructure, there are 3 pieces. They're your devices, and the devices are, your toasters, your elevators, your escalators, your like big heavy-duty machine that stamps out bits of robots in the robot making factory, or it could be something like a Raspberry Pi. Who cares? But they're all sending data to some point in the cloud. And the cloud in question is the cloud gateway. In the case of Azure, that's IoT Hub. And this is basically going to be a huge bidirectional pipeline that allows you to ingest all the data from your millions of devices that are sending data and then give it to whatever is doing your backend processing in the backend. And your backend processing is where the real heavy lifting of what you're doing with the data comes into play. This is where you have your dashboards, you have your machine learning algorithms that can tell when your jet engine's about to fail. It's where you have stream analytics that will trigger when a motor temperature gets above a certain threshold. So this is kind of where the meat and potatoes of your solution happens, and then you have some sort of insight that happens that you send to the cloud gateway back to the devices. And this is what makes cloud infrastructure. So I have some tips and tricks to think about when you're designing your overall IoT infrastructure. And the first is to beware of bottlenecks. You've all probably been in some sort of line where there's been that one person who's ahead of you, and maybe there's like 4 windows, but there's one line, and like there's the one person who's just taking up time at that one person. And you're like, I've got a very simple question to ask, or maybe I just want to buy a ticket, but I can't because this person has some complicated question that they have to ask. Think of your IoT solution and the way it handles the data as that bottleneck. Each different service that you use is designed to handle a different type of load. And just understand what types of data are going to each of the services in your architecture and what are the parameters on it. And just figure out, okay, well, is there something that I'm using that if a certain use case is hit will cause a bottleneck in my system and just back up my whole thing so that I start getting my insights much, much slower than I expected? Or is there something I can do around that? You should also know what to do when things go wrong. This isn't so much from an infrastructure point of view, but a keep on going with things, because I'm sure everybody's written code that doesn't do some sort of fallback check. It's like, if it times out, then what? You probably want to retry. I do this all the time when writing demos. I'm not ashamed to admit it, where you say, oh, well, I don't encounter these couple use cases because there's no way it'll hit that in the demo. And then you're live and the demo gods frown on you, and then suddenly your demo's broken because you didn't account for that check. So on your devices, make sure you have a way to implement a retry. So if the device fails to send data, for example, it can retry that data set. Sounds pretty easy, but it's amazing how many times people forget to do something as simple as that. Similarly, with whatever your backend processing is using, figure out how lossy your system can be. And if it's not acceptable to lose data, then use services with an at least once delivery mechanism. IoT Hub has that, Azure Event Hubs has that, Service Bus Queues has that. Bunch of different Azure services you can use that have that type of, that degree of promise of how often your data is sent. You should also remember to keep tabs on the health of your data. This kind of goes back to the first point of beware of bottlenecks. You need to know what's going on with your system in order to do anything about this. And Azure services have Azure monitoring enabled on, if not all, then most, and soon to be all, that help you keep tabs on that. You can set up alerts on different key metrics. There are logs available for many of the services so that you can set up automated processes so that if something does go wrong, you get notified about it by some automated way rather than a customer calling you on the phone saying, hey, my toaster stopped making toast. And you're like, oh, let me go figure out what's going on there. So monitor your backend services. It's very, very important. And last but not least, if you're going to be global, then be global. This isn't so much an infrastructure as an all-up type of deal. Know what's required for all the different regions that you're rolling out to. So for example, if you plan on putting out a solution in Germany, and you are unaware that Germany has very, very different data privacy laws than we do in the US, you are going to be in for a world of hurt when you try to enter that market. Know what's required for your market, know what compliance is there, and know what's required for your industry itself. Everybody knows that the medical field, or everybody should know that the medical field has also strict laws about data privacy. Just know that you're compliant and be able to prove that you're compliant before you approach a customer. Many Azure services, including IoT Hub, are compliant with a number of different certifications. If you go to the Trusted Computing Center, I think is what it's called, you can see a list of all the different Azure services and which compliance certifications they're going for. This is something that Azure takes very, very seriously, and we go through a yearly audit cycle so that every new service goes through and gets audited for the first time, and every existing service gets re-audited to make sure we're still compliant with all the certifications, because we know our customers rely on those. Great, so these are all wonderful tips and tricks to keep in mind no matter what you're doing with your architecture. Now let's dig a bit more into what the data is all about. What's really going on with data processing? So data really is the lifeblood of IoT. If you don't have data, you don't have an IoT solution. You just have some devices that have some fancy internet button that you can access through your phone. When you're considering your data, think about how all your data will be stored, extracted, mapped, searched, sorted, and just overall computed upon at every point along your architecture. And think about how frequently you're sending your data and why you think you need to send data that frequently. Now, that being said, there are some devices where the legitimate way to collect data is to send one data packet once a week or once a month, depending on how, like maybe it's a smart power meter. Those who need to phone home all the time, they just need to be phoning home around billing time. But those are really painful to debug because you don't want to have to come in, Thursday at 10 p.m. when your smart meter is scheduled to power up in order to actually go through and say, oh, well, here's how much the power is used in order to debug the solution. It's okay to send it more frequently during debugging. Just don't forget to turn it back down again. Some customers have been very upset when we're like, we're using up all our quota, and we're like, well, how frequently are you sending the data? And they're like, oh, we fixed it. Never mind. Like, all right. So I do have some tips and tricks about data processing as well, and these are applicable no matter what you do with your data, and you might notice that there's a theme. I work on IoT Hub, where we deal with these types of issues that customers have often. And first and foremost is challenge your data assumptions. Why are you sending data as frequently as you are? One of my colleagues and I had a call with a customer about a year ago, actually, at this point, and they were trying to convince us that they really needed to send 1 terabyte of data to the cloud every second. 1 terabyte. We didn't even. We're just like, are you sure? And they're like, yes. We're like, are you positive? Like, did you do the math on this? Because this is a terabyte of data. Like, that's a lot of data every second. Like, can you process this? And they're like, we will be able to. And we're like, oh yeah, sure you will. And this brings me to the next point. Understand how much data you're sending to the cloud every day. Just do the math. Take number of devices times average data packet size times data frequency, send rate. Multiply that together, and if that number is really, really big and much bigger than you thought it would be, like a terabyte of data every second, then maybe you want to reevaluate your assumptions, go back to the first part, and change how you're doing your architecture and say, okay, well, actually, I can reduce my bill if I just, reduce my send frequency by a little bit, and that would be great because I get the same insights out of it. Speaking of which, please don't spam the back end. Like I mentioned earlier, know what the tolerances of your different services are. Don't spam them, please. Just when you do the math to figure out what's going on, make sure that you have your services properly configured. And if, like I mentioned before, you're using Azure Monitoring to say, oh, hey, my service is having a problem because it's getting slammed because one of my devices is malfunctioning and sending data once a second instead of once a minute, then you can actually know what's going on and fix it. So just kind of be aware of how your data is flowing through the system and how much data you expect to be going through the system at every step along the way and how long that processing will take. All of these have to do with how your data flows through the system and making sure that is optimized. And finally, you should know what you're doing with your data. I cannot stress this one enough. I found that there were kind of 2 general types of customers. They're the customers who will, spend 6 months trying to figure out what to do with their data and basically trying to teach themselves to be data scientists before saying, well, we're no good at this, and they either move on or they'll break down and finally hire a data scientist. Or there's a second type of customer who goes, we don't know what to do with this data, and then they hire a data scientist, and the data scientist figures out what to do with the data. So if you need to hire a data scientist, I highly recommend it. This is what they're trained to do, is figuring out insights from large pools of data. Like, it's fine. Good data scientists are practically worth their weight in gold. Some of you might have been wondering when I actually talk about the devices. And the reason why I save devices till the end is because devices tend to be the first step for IoT hobbyists who tend to go, hey, cool, a Raspberry Pi. What can I do with this Raspberry Pi? And that's fine. But with an enterprise workflow, they tend to occur a lot later in the cycle. Because when the enterprise are like, OK, well, we want to optimize our elevator business, to use our customer ThyssenKrupp elevators as an example. And they say, OK, well, what types of things can we do with our devices? And they kind of work from what business outcome do we want to achieve down to how can we affect that in the physical world. Now, there are two main types of devices or families of devices that you can consider. There are greenfield devices, which are brand new devices that are custom-made for your solution, and then there are brownfield devices. And brownfield devices are the ones that already exist in the field. They're the ones that have such wonderful facts as like they use a legacy data protocol, they use a legacy networking protocol, or an industry-specific protocol, and they might use some obscure programming language and have some sort of pre-existing software that somewhere up your management chain wants to leverage, because they figure it would be cheaper to reuse this existing piece of data that's written in COBOL rather than create a new device, program it in a new, more modern language, and then maintain that for 20 years. So that being said, the grass isn't necessarily greener in the greenfield devices, because remember that today's greenfield device is tomorrow's brownfield device. And you have to make all these decisions when you're creating a greenfield device, like how many ports will it have? What networking protocol should I use? What language should I program it in? How many ports ought to it have? How am I going to secure this device physically? How am I going to secure this device digitally? And all these different things that when you actually produce the device at the end of the day, you want to make sure that 5 years from now, when this device has been in the field and has been working properly, hopefully, you don't wish you had a time machine to go back in time and slap yourself upside the head and say, hey, why did you make that decision? This device is nearly impossible to manage. So keep these in mind when you're choosing the devices. That being said, in industry, sometimes you have more or less of some wiggle room in determining your device. So if you do have the opportunity of going greenfield, make sure you learn from the mistakes of your brownfield predecessors. Now, as before, I do have some tips and tricks about the devices. And first and foremost is to know the device lifecycle. This isn't just the device lifecycle that actually a colleague and I will be talking about tomorrow at one of the breakouts at 9 a.m., but just how long is your device expected to be in the field? Is it 5 years? Is it 10 years? Is it 30 years? The least I've heard a customer say to me is 10 years, and they were extremely uncomfortable about that. They're like, well, if we have to, it'll be 10 years, but really we want it to be 15 or 20 years in the field before we can retire it and end of life it and move on to the next hardware that we might be working on now. So make sure you know how long your device is supposed to be in the field in order to make sure you can actually maintain it properly over the lifetime of that device. Upgrading firmware is a pain in the ass. Please take the required precautions before you actually go and upgrade any sort of firmware. So this could be, make sure that your smart car doesn't decide that as soon as there's a new version of firmware, it just immediately updates it, because you'd hate to be driving 60 down the highway and then suddenly your car reboots because, oh, it's Patch Tuesday, I got a new patch, which is why, oftentimes you need to make sure your device is able and willing to take on new firmware before it actually takes it on. I mentioned earlier that Azure Monitoring does a lot of great monitoring for your services. You also have to manage the health of the devices as well. So devices often send telemetry data about the state of the world around them, but you also need to measure the state of the device itself. What's its RAM usage look like? What's its CPU? Make sure all of that is within normal parameters, because oftentimes that's how you tell when your device has been compromised, is your CPU spikes. You're like, oh, hey, somebody's running something on my device that I did not intend. And so monitoring the health of the devices can also help you monitor the state of the security of your devices in the field. And finally, be open to change with your device. I know that oftentimes there's not that much wiggle room here, but sometimes there is. Sometimes you might be able to convince upper management that it's actually worthwhile to rewrite this critical legacy piece of code in a newer protocol or a newer language just because it'll actually save you maintenance costs in the future. So don't be afraid to make those types of arguments if you need to get your point across about how to make this whole solution maintainable from the devices to the cloud for the foreseeable future. So I want to end with something I remind myself of frequently. Don't be data dumb. Know what your devices are sending, know what's going on with your devices, and know what's going on with your cloud backend. So know what you're designing for, question everything, and think big. Thank you very much. Now, if any of you do not have questions, feel free to head over to one of the other talks or talk to any of my colleagues at any of these wonderful booths. If you do have questions, I'm going to be heading over to the cloud platform section in the Azure IoT portion. So if you have questions, you can follow me over there and ask me en route, or just stand around and ask me while I'm actually at the booth. Thank you very much.